Okay, in this video we're going to go over the 4.5 homework day 2 from the textbook. So problem 21, the key is you want to recognize that you're going to not need the product rule because this is a function but this is a number. Okay, so your derivative, and I'm just going to call it y prime, is just going to be do the power rule. So I'm going to have 2t be in front with the power rule, and natural log of 4 just comes along as a follow along. You may be more comfortable writing it like this, so you get the idea that this piece is just a number times t. Okay, so that's 21. Okay, 22, you want to recognize that they're asking you for the second derivative. So what I would recommend that you do is write your function like this. All right, now go ahead and take the first derivative. So it's natural log. So we know that that derivative is not going to have natural log in it. It's just going to be 1 over x plus 1 times the derivative of that, which is just 1. So basically your y1 will be just 1 over x plus 1. Now you're not done because they are asking you to take the second derivative. So take the second derivative and you're going to use the quotient rule. So you're going to say low, which is x plus 1, d high, which is 0, so that's going to fall away, minus high, which is 1, d low, which is also 1, so you just have minus 1, over x plus 1 squared. Okay, so your answer, carefully, because you can easily lose that negative sign, is just that. Okay, so that one's done. We've got 2 done. Okay, let's go to another one. So 23 also says to take the second derivative. Now, this may look a little confusing to you this way, so what I'd probably recommend is that you do this. Write it like that. So now you know that you're going to use the power rule. So y prime equals 3 times the natural log of t. Okay, all this quantity is then squared times that derivative, which is 1 over t. Okay, so that is your first derivative. Okay, so let me just clean this up a little bit so I'll make this look nicer. So I'm going to get rid of that, and I'm just going to put it under here. So then I'm ready to take the next derivative. Okay, so the next derivative, y prime prime, now I'm going to use the quotient rule. So low, d high. So d high is going to be 6 times natural log of t, and then you're going to have to take the derivative of natural log of t, which is 1 over t. Okay, and what's going to happen is those t's will cancel in just a second. Okay, so I did low d high minus high d low, which is just 1. So, and this high has a squared. So let me do that. Okay, all over t squared. Okay, so let's clean this up a little bit. And I'll change color so it's easier to see what I'm doing. Okay, remember this t I said is going to cancel this t up here. So my final answer is going to be this, and I'm going to kind of box this off a little bit. Okay, so it's going to be y prime prime equals 6 ln t minus 3 ln t quantity squared all over t squared. Okay, done. Okay, going on to the next problems. Okay, number 24 says, find the equation of the tangent line to the graph of y equals natural log of the absolute value of x at x equals 1 and at x equals negative 1. Now, the reason why they have that absolute value symbol is so that you can use both of these x's. Without that absolute value symbol, you would not have been able to use the second x equals negative 1. Okay, so let's just take the derivative. Y prime equals, the absolute value sign doesn't change my derivative. It's still going to be just 1 over x. Okay, so that's my derivative. So now what I'm going to do is remember that I have to say y minus y1 equals m times x minus x1. Okay, those are my equations of tangent lines. So the first one is going to be y minus natural log of 1, okay, equals, what's the slope? The slope will be 1 over x minus 1. Okay, that's your first equation. Now, because natural log of 1 is 0, you can change that to y minus 0. So let's do that now. Okay, so I'm going to change this to 0, and now I'm really good. So that's my first equation. Now I have a second one because I have a second x. So that's going to be y minus, it's still going to be y minus 0, because natural log of the absolute value of negative 1 is exactly the same as the natural log of 1. So that's going to be 0. My slope this time is going to be 1 over negative 1, so it's going to be negative 1, and then this sign will flip. Okay, so that's the second problem. Okay, number 24 says write the equation of the tangent line to the graph of y equals ln of x squared plus e at x equals 0. Okay, so you're going to write the equation line. I need to know that I'm going to be in this format again. Okay, and I have to take the derivative. So y prime, because that's going to get me my slope, equals 1 over x squared plus e times 2x. Remember, e is just a number, and the derivative of a number is 0, because the number is just a constant. Okay, so don't lose track of that information. Okay, so that's what I have for my derivative. So now I'm ready to plug in. So if I plug in, I'm going to evaluate y prime where x is 0, and that's going to give me 0 over, and it's going to be 0 squared plus e. So that means that slope is just 0. So this is 0. What is x? Well, x1 is also 0. Okay, so then I have y minus y1. Okay, so y1, let's figure that out. So if y equals natural log of 0 squared plus e, so that's y1. So y1 will just be natural log of e, which we said previously was just 1. So y minus 1 equals 0 times x minus 0 is going to be your equation of the tangent line, but clearly we can change that to just y equals 1 and be done. So you've got a horizontal tangent line. Okay, so that's 25. So let's go on. We're going to go to 27. Okay, 27 shows us a graph, and it's the graph of ln x over radical x, and they want us to find the coordinates of the maximum point. So we're basically trying to find that point right there. Okay, so we're going to do that. So coordinates, I need the x and the y. I don't need to test it necessarily. They already told me it's the maximum point. If I only get one critical value, I'm done. Okay, so let's take that derivative. So this is going to be low, which is x to the 1/2, d high, which is 1 over x, minus high, natural log of x, d low, which will be 1/2 x to the negative 1/2, all over radical x squared is just going to be x. Okay, set that equal to 0. All right, since I know if I do cross products, I know that this is going to be equal to 0 when my numerator equals 0. So look what I can do. I'm going to take the first term in my numerator. Okay, so that's going to be this term, and I'm going to write it. So this is x to the 1/2 over x. Okay, I'm just going to leave it like that. I'm going to set that equal to the rest of my term here, and that's going to be, let's see, I have natural log of x in the numerator. I will have 2 x to the 1/2 in the denominator. Okay, so look what I have. I have fraction equal to fraction. So I can do the cross products. So doing the cross products, I'm getting 2 x to the 1/2 times x to the 1/2 is x, and that's going to equal x natural log of x. Okay, so I'm not done yet because I haven't isolated x. I've got x all over the place. Do not, at this point, divide by x because that will drop a root. So I'm just going to bring the right-hand side over, set it equal to 0. I'm now going to factor and get 2 minus natural log of x equals 0. Okay, I have 2 possible roots, x equals 0, and natural log of x equals 2. Do you see that? So let's think about the x equals 0. Can I actually use x equals 0 in my original function? And the answer is no for 2 reasons. You cannot take the natural log of a number that's 0 or less, so that eliminates it from being a contender in the numerator, and you certainly cannot divide by 0. So it's eliminated from being a contender in the denominator. So there's no way that this x is going to be used. Okay, so this guy is gone. Okay, so now look at the other one. I don't really have x yet. I have an expression that includes x. So what I'm going to do is I'm going to say, okay, x is locked up. I'm going to change the form. The base is e. Logs equal exponent. The exponent is 2. That's what equals x. So here is my x value. I'm halfway there to getting my coordinate. Okay, so far for a coordinate, I have e squared. Okay, so now you have to evaluate your original function at e squared in order to get your y value. So this is that, and this is going to be e squared square root. Okay, so look at the first term. How about if we just write that using our power property? So that's 2 ln e. And if I take the square root of a squared term, don't I just get an e back? Okay, and don't I know that natural log of e, this whole thing, is going to equal 1. So my y value is 2 over e, and that is the point I was looking for. Okay, done. Okay, let's go on to the next one. Okay, find the coordinates of the relative extreme point of y equals x squared natural log of x, and x has to be greater than 0. Then they want us to use the second derivative test to decide if the point is a relative max or a relative min. So I need a point, x and y values, and I need to take a test, second derivative test, which is a test of concavity, to figure out if I have a max or a min. So next thing you have to recognize is that this is going to be the product rule. So y prime equals left x squared d right plus right d left. Okay, so let's clean that up a little bit. And so I have just x here, and then pull that 2x in front. Okay, so that's what I'm getting at this point. So that's going to be set equal to 0. Just like we did last time, do not drop any roots, factor out your x. So y prime equals x times 1 plus 2x, 1 plus 2, let me just, is that? So I factored out an x, so 1, 2 natural log of x. All right, so I have 2 possible roots. One is going to be x is 0, so here's a root, x equals 0. Here's another root, 1 plus 2 natural log of x equals 0. Look at your original function, and you'll recognize that you cannot take the natural log of 0, so this cannot be used. Okay, so I'm left with this. So what is this? This is 1 equals negative 2 natural log of x. Okay, get your x by itself. Divide by the negative 2. That equals natural log of x. Okay, x is still locked up. Change your form. Your base is e, logs equal exponent. Your exponent is negative a half, and that is what equals your x. Okay, so right away I have my x. Okay, so then we have a couple of choices here. We need to take the second derivative and evaluate it, so we might as well just do that first. So I'm going to take the second derivative. So I'm going to do, well, I guess either one is fine. So I'm going to work on this. So the derivative of that is, well, actually, let me not do that. Let me work on the other one, because that'll be more straightforward, I think. So let's use this form. Okay, that derivative is 1 plus, now you've got to do the product rule. Left, d right, plus right, d left. Okay, so let's clean this up. These can cancel, and that becomes a 2. So my y prime prime equals 1 plus 2, which is 3, plus 2 times the natural log of x. Okay, so now let's evaluate it. Y prime prime evaluated at e to the negative 1/2 equals 3 plus 2 natural log e to the negative 1/2. Remember, we can bring this down in front, so it's 3 plus, and that's going to be a negative natural log of e. Okay, natural log of e is just 1, so that's 3 minus 1, which is 2, which is greater than 0, which tells me I have a min. Alright, so I know it's a min. Now let me just change color so we can see a little bit clearer. Okay, so now I need to get that y value. So go back up to your original function. So y equaled x squared. So that's e to the negative 1/2 raised to the second power times the natural log of e to the negative 1/2. Okay, so what is that? So it looks to me like the first number here, if I raise negative 1/2 squared, I get e to the negative 1. So isn't that like 1 over e? And then what about this other one? Don't I get negative 1/2 natural log of e? So isn't this 1? So isn't that times a negative 1/2? So that makes this a negative with a 2 in front. So my y value is negative 1 over 2e. You may want to go through that a little bit slower just to make sure you understand how you are manipulating natural logs to get numbers. Okay, that brings us to 31. So 31, it says, if a cost function is this, find the marginal cost and evaluate it when x is 10. Okay, so we basically are going to find this. That's our goal. Okay, so c prime of x equals low 40 minus 3x d high, which will be 100 over x minus high, which is 100 ln x, d low, which is just negative 3, all over 40 minus 3x squared. Okay, so I'm just going to do one thing to clean up a little bit. Okay, I'm still going to keep this as 40 minus 3x 100x, what I'm going to do is bring that negative 3 in front. So make that positive 300 natural log of x all over 40 minus 3x squared. Do not cancel anything because you don't have the rule of 3 going on here. Okay, what I'm going to do next, since I see that 10 is such a nice number to plug in, I'm going to plug it right in. Okay, I'm not going to play around with cleaning things up any further in my derivative. I'm just going to plug in my 10. So what's 40 minus 3 times 10? 40 minus 30 is just 10. So this is 10, and this is 100 divided by 10, which is also 10, plus 300 times the natural log of 10 over, and then this is 40 minus 30 squared, so that means it's 10 squared, which is 100. Okay, so I'm going to factor out 100 from both the numerator and the denominator. Okay, and I get in the numerator 1 plus 3 natural log of 10. Okay, so these can cancel, and my c prime of 10 is 1 plus 3 times the natural log of 10. All right, and we are done. So that's your best answer for that. Okay, let's go on to 33. Okay, 33 says, suppose the demand equation for a certain commodity is this. Determine the marginal revenue function. Okay, you have to remember that marginal revenue equals price times quantity. What did they give you? They gave you price. So first off, I'm going to tell you, excuse me, I shouldn't have said marginal revenue. I should have said revenue. So first thing I'm going to do is make sure that I know I have a revenue function. I'm not going to start working on this price function. So multiplying by x gives me something slightly different than what I was given initially for this problem. Okay, so then once I take this derivative, I'm going to get this. So basically, I'm looking for marginal revenue and evaluating it at 20. So R prime at 20 is what I want. Okay, so I look at this. Can I do anything with properties to make things simpler? And the answer is no. So I'm going to take my derivative. Low d high minus high d low over low squared. Okay, so it looks to me like these can cancel. So at this point, let's see what we're going to do. So I have that. Why not just plug in for 20? Okay, so R prime of 20 is going to equal the natural log. Well, actually, I'm going to pull that 45 in front because I don't like that. So let's pull the 45 in front. 45 times the natural log of 20 minus 45 over the natural log of 20 squared. Okay, so I could make this look prettier. This would be 45 times the natural log of 20 minus 1 over the natural log of 20 squared. Okay, that's the exact answer. If you plug it in your calculator, you'll get approximately, so not exactly, but approximately 10. And that completes the homework.